This conference will now be recorded.
So today about types of links. There are two types. One is soft link, the other one is hard link. So what is soft link? What is hard link? Before that, you need to understand what is inode. What is inode? And inode is the pointer to the file. Inode is a pointer to the file. Every file has a unique inode number. Every file has a unique inode number. Number of inodes means number of files. So no difference between inode and file. Both are same. When I create the file or directory, it is going to create one inode number. For every file, it's going to create one inode number. What's the command to create the file? Anyone? What's the command to create the file?
Cat greater than.
Don't say cat. Touch. The command to create the file means touch. Touch name of the file, file1. Now you tell how to see the inode number for this file1. ls-i, ls-i file name. I stands inode number. Touch file name file1. ls-l name of the file file1. Sorry. ls-i file name. This is called inode number. Every file has a unique inode number. ls-a to see the inode numbers, for all the files in the current directory. So every file and directory has a unique inode number. So coming to the soft link and hard link.
ఉషా అంటే
This conference will now be recorded.
కరెంట్ బిల్ అంటే
Now what is soft link? Here, for example, you have original file and linked file. My original file is file 1. My linked file as file 1. The name of the linked file can be any name as you wish. Original file is file 1. Linked file is S file 1. In soft link, if original file inode number example 2048, original file inode number 2048, linked file inode number 4096. In soft link, the inode number for original file, linked file cannot be seen. Here I create the file called file1 and touch file1 ls-i file1. What is my inode number? Let us say 1, 2, 3, 4, 5 is my inode number. How to write the data in the file? Through cat rva. Cat greater than name of the file file1. If I write some data in the file, control D for save. If I write the data in the file, what you feel that data storing in the file 1, data is writing in the file 1, but data won't be write in the file 1. Data is going to write inode number, not in the file 1. Whatever data we are writing in the file, the data being stored where? Not in the file, in the inode. Data will be stored in the inode, not in the file. How to read the file cat file name? If I type cat file name, it will collect the data from the inode and store in the file. Take the data from the inode and store in the file. So we are writing the data in the inode through file. We are reading the data from inode through file. So to understand soft link and hard link, first of all, you have to clear this concept. You can't write directly in the inode number. We are writing through file. We are reading through file. Now coming to the soft link, my original file inode number 2048 and linked file inode number 4096. So if I create the linked file, already we have some data in the file 1 that is there in the 2048. With this for this file 1, I create the linked file as file 1. For this as file 1, the inode number is 4096. To read the data in the file 1, I can read the data from the file 1 or I can read the data from S file 1. The data in the file 1 we can read from S file 1. If I type cat S file 1, S file 1 refers file 1. S file 1 refers the file 1 because original data in the file 1 only, not in the S file 1. S file 1 refers file 1, then file 1 refers to 2048 and we are able to see the file. So the data in the file 1, I can read from the original file or I can read from the linked file. That is called linked. Tomorrow, if I update, if I update S file 1, If I update S-file1, can anyone tell where this data is going to write? If you're writing the data in the S-file1, where the data is going to write? Anyone? You feel that data is writing 4096, but data won't be right here. Data is going to write in file 1 from file 1 to 2048. So whether you are writing the data in the file 1 or S file 1, finally data is going to write in 2048. This is called soft link. If the size of the file, original file is 4 KB, size of the file, original file is 4 KB, what would be the size of the linked file? It shows that 0 bytes. Why 0 bytes? Nothing is there 4096. So wherever we write the data, final data is going to write 2048. S file 1 contains does not contains any data. It's a 0 bytes, empty file. This is the concept of soft link. Any questions? Next, hard link. My original file is file 1, linked file is H file 1. Here in the hard link, inode number for original file and linked file always same, cannot be different. For example, inode number 4096. For both the files, inode number inode number remains same, no different. Now, if I write the data in the file 1, data is going to write inode number 4096. This data I can read from H file 1. If I type cat H file 1, it refers 4096, color the data. If I write in the data H file 1, it writes data in the 4096. I can read from the file 1. So wherever you write, final data is going to write in 4096. So both the files share the same inode number. In a soft link, if linked file is removed, no problem. We can read the data from the file 1 because of data in the 2048. But original file is removed, linked file you cannot access because no data in the 4096. Data stored in 2048. If original file is removed, linked file we can't able to access. The original file should be always available. It is like shortcut in Windows. Whenever we install any third-party software, any application, a shortcut by default create. Where the original software installed under C drive programs folder. Every time you want to open that application, you have to go to C drive programs folder. Instead of that, if I create the shortcut, we can open that application from the desktop. If original file is removed, shortcut file we can't able to access. the version file should be always available. Whereas here, if file 1 size is 4 KB, H file 1 size also 4 KB. Why? Because both the file having same inode number. Here, the advantage is even the version file is removed, we are able to access the data from the linked file because of same inode. Is it clear, guys? Any questions? Okay. See, First, discuss about softly. Create some directory, any directory that is there. Create a file, cat greater than name of the file, file1. Write some text. Control D for save. How to see the inode number for this? ls-i, name of the file, file1. So this is the inode number. I'm going to create the soft link for this file, ls-s, name of the file, file1. ln stands link, ln stands link, hyphen s stands soft link, hyphen s stands soft link. Sorry. File1, original file, linked file, s file1. So file1 is my original file, linked file is s file1. ls-i, double 36642, inode number for file1, and this is the inode number for s file1. So for both the files, inode numbers not same, both are different. So the data in the file1 I can read from s file1. Anything you update in the s file1, anything you update in the s file1, this data I can read from file1. This is called soft link. But whatever data we are writing in file1, the actual data is going to write in the file1 only, not in the s file1. When you see the size, du-h to see the size, file1, 4 KB, du-h s file1, showing that 0 bytes. Why? Because if you write the data as file1, data won't be stored here. Data is going to write in the file1 only. That's why it is showing that 0 bytes. Tomorrow, version file is removed. rm file1, cat s file1, no such file or directory. The file is there, but you can't able to access because the original file is removed. How to see the type of the file? ls-l or double L. Double L stands long listing. ls-l or double L both are same. So L stands for linked file. Also we can type file name. What is the file? Symbolic link. Symbolic means what? Soft link. This is about soft link. Original file should be always available. Come to the hard link. Create the file type file1, ln file1, h file1. If I use ln-s, that is soft link. ln-s soft link. Without -s, that is hard link. First write some data or ln file1, h file1. Currently both are empty. Write some data in the file1. Control D. Cat file1. Same data I can read from h file1. See the inode numbers ls-i, both the files having same inode number, no difference because it's a hard link. Anything you update in the H file 1, Control D, cat H file 1. This data I can read from file 1. See the size of the files du-h file 1 4 KB, du-h h file 1 also 4 KB. So what is hard link? Hard link is backup. Hard link is a backup. So even the version file is removed. What is the meaning of backup? Even the version file is removed, we are still able to access the data from the file 1, H file 1, linked file. That is called backup. So difference between soft link and hard link. In soft link, the inodes of both files cannot be the same. Inodes are different. Whereas in hard link, both the files share the same inode number. In soft link, the size of the original file, linked file cannot be the same. Whereas in hard link, size of the original file, linked file always same. In soft link, original file is removed, the linked file we cannot access. Whereas in hard link, even the original file is removed, the linked file we can access. Soft link like a shortcut in Windows, whereas hard link is a backup. Then what is different between what is the purpose of CP command? What is the purpose of CP command? Anyone?
Copying the file.
Where do you want to copy?
Destination.
Where do you want to copy? What is the purpose of copying the file?
To have the same contents of copying file.
Why? What is the purpose? For
To have
backup,
backup.
right?
Yeah.
Tomorrow file 1 got deleted, you have a backup H file 1. So copy for backup. Hard link also backup. And what is the difference? Both are for backup. Then what is the difference between CP command and hard link? Anyone?
If we delete original file, linked file is called. But in copy, we will have a different file. So one is deleted, another will be present.
No, just now I told you the advantage of hard link. Even version file removed because of same inode number, I can access data from the H file 1. Inode number is same, right? There is the advantage of hard link. In soft link, version file should be available because actual data write in 2048 only, not in the 4096. Version file should be available. But whereas both the file having the same inode number, even the original file remote also we are able to access. Just now we have seen the practical also. Then what is the difference between copy command and hard link? In copy
If we use
command,
copy command and update anything on file one, it will just update file one only. You can't see that update on the H file one if we do the copy. But in case of
eh,
hard link, we can see both.
yes, very good. So for example, in file 1, the inode number 123 something. For H file 1, what is the inode number? 345. Both are not same. In copy command, both the files does not have same inode number. It is different inode number. So what is the problem? Tomorrow file 1 is updated. It won't update H file 1. Again we have to copy. It is like Xerox copy. Today class you have notes in of today class only. If you Xerox it, tomorrow if a notes is updated, again you have to make a Xerox, like CP command. But whereas here, if file 1 is updated, the same data without copying, I can read from H file 1. H file 1 is updated, immediately I can read from the file 1 because of same inode number. It is also backup, it is also backup. But here, every time you have to copy, here not required. So that is different between soft link and hard link. So okay guys, we have done everything basic commands. Tomorrow we are going to start Linux administration part. So any questions? Okay, see you tomorrow, same time.
Thank you, sir.